In this video, let us solve the numerical problems 2. The first question is calculate the approximate and exact alkalinity of water in milligram per liter as ESE3 containing 75 milligram per liter of bicarbonate ion and 100 milligram per liter of CO3 2 minus carbonate ion, given the pH is 10. So to calculate approximate and exact alkalinity, let us write the definition. The alkalinity, which is basically the exact alkalinity, is simply the concentration of all the basic ions, that is HCO3 minus ion concentration plus CO3 2 minus ion concentration plus OH minus H plus. The approximate alkalinity, we neglect the concentration, or we neglect this difference between OH minus and H plus concentration. Particularly if it is at neutral pH, this would be equal. So the approximate alkalinity is equal to concentration of HCO3 minus and so since we need to express it as milligram per liter as CaCO3, we have to find equivalent concentrations and then multiply with the CaCO3 equivalent. So let us start with the first one, that is HCO3. HCO3 minus ion concentration is 75 milligram per liter divided by its equivalent weight. Its equivalent weight is HCO3 is 61 is the molecular weight, divided by valency is 1. So this is the equivalent concentrations. Then multiply it with 50 gram per equivalent of CaCO3. So we get 61.5 milligram per liter as CaCO3. Next, CO3 2 minus concentration is given as 100 milligram per liter divided by its equivalent weight. It is carbonate ion, equivalent weight is 60, divided by its valency is 2. So we get, then multiply with 50 gram per equivalent as CaCO3. Then this you get around 166.7 milligram per liter as CaCO3. So now we have to calculate concentrations of OH minus ion and H plus ion. So for this we use the information of pH. Since pH is minus log concentration of H plus, and this is given as 10, it implies concentration of H plus is 10 power, so base 10, so it is 10 power minus 10. 10 power minus 10 mole per liter. But since it is H plus, you can even say 1 mole is equivalent to 1 equivalent. So it can also be written as minus 10 equivalents per liter. Similarly, calculate concentration of OH minus. For this we need the relation between pH and pOH, which is equal to pKW, which is 14. So which means POH is 14 minus 10, that is 4. So which means concentration of OH minus ion, this is minus log OH minus concentration to the base 10. So which means concentration of OH will be 10 power minus 4 mole per liter. Since OH minus ion also produce, since valence is 1, we can say it produce 1 equivalent, so it is 10 power minus 4 equivalents per liter. So both are in equivalents per liter. Just convert this equivalent into equivalent weight. So this would be into 50 gram per equivalent into 50 gram per equivalent. So concentration of H plus is equal to 10 power minus 10. If you write it in milligram per liter, then just take divided by 10 power minus 7 into 10 power minus 3, 50 milligram per liter. So this would be 5 into 10 power minus 6 milligram per liter as CaCO3. Concentration of OH minus ion is 10 power minus 4, which is 10 power minus 1 into 10 power minus 3, that is milli. Then we have grams per liter into 50, so which would be 5 milligram per liter. So now we have concentration of H plus, OH minus ions and carbonate and bicarbonate ion. So if we sum up appropriately, we get the result. So first approximate would be HCO3 plus CO3 2 minus, so it would be 166.7 plus 61.5. So this sums to around 228.2 milligram per liter as CaCO3. Exact one would be, to this we have to add 228.2 plus concentration of H plus, that is 5 into 10 power minus 6 plus concentration of OH is 5 milligram per liter. So this is negligible, we can just add these two. This would be 233.2 milligram per liter. Let us go to the second question. Second question is a 200 ml sample, 200 ml sample of water has initial pH of 10, 30 ml of 0.02 normal H2SO4 is required to titrate the sample to pH of 4.5. What is the total alkalinity of water in milligram per liter as CaCO3? So one is we have to calculate total alkalinity. The other one is if the pH 8.3 is reached at 11 ml of acid, determine the quantities of OH minus CO3 2 minus HCO3. Okay, so we have given here the concentration of H2CO4, that is acid, in normals. Okay, and pH is given. So as we know how the alkalinity changes with the amount of addition of acid. First, if there is a CO2, that CO2 get neutralized. Then before CO2, OH minus get neutralized. After that, CO3 2 minus get neutralized. After that, HCO3 minus neutralized. So we have to compute how much OH minus is there, how much CO3 2 minus, and how much HCO3 is there. So based on that, we can determine the individual concentrations. But the total concentration neutralized is given, that is by using 30 ml of 0.02 normal H2SO4, and it is used to neutralize 200 ml of water. Okay, right. So let us start with the first question. What is the total alkalinity of water? Right. So the amount of alkalinity which is present in the water is equal to the amount of alkalinity that can be neutralized by this acid. So if 30 ml of acid is consumed, how much alkalinity will be neutralized? Okay, so if we take maybe let's start with 0.02 neutral, 0.02 so normal means equivalents per liter. So 0.02 equivalents present in 1 liter of the sample, or you can say 0.02 equivalents present in 1000 ml of the sample. Then here it is taken 30 ml of the sample. So how many equivalents are consumed by the 200 ml of water? That is equal to 2 into 3, 6, 10 power minus 3. Okay. This is 2 into 10 power minus 2. So 0.6 into 10 power minus 3 equivalents are consumed. Okay. So 0.6 into 10 power minus 3 equivalents, or you can say 0.6 milli equivalents are consumed. 0.6 milli equivalents are consumed means same amount of alkalinity is there in the 200 ml of water. So if you express it in maybe 1 liter of water contains how many equivalents of alkalinity, you can simply divide 0. Milli equivalents divided by 200 ml, or you can say 0.2 liters, which means 3 milli equivalents. 3 milli equivalents are there in a liter. Should be 3 into 1 equivalent would be, if you express it in CaCO3 concentrations, it would be 50 gram per equivalent. So this would be 150 milligram per liter. So 150 milligram per liter is the total alkalinity. Basically only 200 ml sample is there, but if you express it in liters, then it would be 150 milligram per liter is the total alkalinity. Then this is the total alkalinity consumed by all the three ions, OH minus ion, CO3 all these three together consumed 150 milligram per liter. But in the sample you can say out of 150 is there in 1000 ml, then into we have only 200 ml sample, so which is basically 30 milligram per liter is there. 30 milligram per 200 ml sample is there in the water. So in the sample it is only 30 milligram, but if you express it in liters, then it would be 150 milligram per liter. So next let us calculate the individual ones. As we know, the first OH minus ion would be consumed, followed by CO3 minus and followed by HCO3. And then in variation of pH, at 8.3 pH, at 8.3 pH all OH would be consumed plus half of the CO3 minus would be consumed. Then remaining between 8.3 to the final pH, that is 4.5, the remaining half of CO3 minus and HCO3 minus would be consumed. So which means we need to know the concentration of OH minus ions, which can be determined by you can determine it from the pH value. So at pH value we have pH is equal to minus log concentration of H plus, the given pH is 10, but we need concentration of OH minus ion, so POH would be minus log OH minus ion is equal to 14 minus 10, because total pK for water would be 14, so this would be 4. Then concentration of OH minus ion is 10 power minus 4 mole per liter, which is nothing but 10 power minus 4 mole per liter means 10 power, as you have seen, 10 power minus 1, remaining 10 power minus 3 I can write as milli equivalent per liter. If I express it in CaCO3 concentration, this would be 10 power minus 1 into milli equivalent in CaCO3 would be 50 gram per equivalent, so which would be concentration of OH minus ion would be 5 milligram per liter as CaCO3. Now, which means if there is 1 liter of sample, 5 milligrams of CaCO3 would, as CaCO3 of OH minus ions would be there, but the sample is only 200 ml. 200 ml sample, how much OH minus ions are there? So you can just divide 200 ml into 50 milligram divided by 1 liter, that is 1000 ml. So this would be 5. This is 1 milligram. So the sample contains, this 0 is not there, it is 5 milligrams. Sample contains 1 milligram of OH minus alkalinity. Now for consuming 1 milligram of alkalinity, how much amount of 0.02 normal H2SO4 is required? So the amount, the ml required would be, you can calculate maybe by using 0.02, let us say xml. Let us say to neutralize this 1 milligram, let us say it requires xml. Then xml contains how, as per the 0.02 equivalent, it would be 0.02 equivalent per liter into the 50 gram per equivalent as CaCO3. So this should come as 1 milligram. So you can compute now x would be 1 milligram by 0.02 into 50. So this would be 1 ml. So sample contains 1 milligram of OH minus ion, and to neutralize 1 milligram of OH minus ion as CaCO3 neutral alkalinity, we need 1 ml of acid. So it is given in the problem, total 11 ml of acid is taken or is consumed to reach pH 8.3. Out of this 11 ml, 1 ml is for OH minus ion. So the remaining 10 ml is for, you can say the remaining is for the half of the CO3 2 minus ion concentration is for used for CO3 2 minus ion, but this is only half of total CO3. So 10 ml, like 1 ml neutralizes 1 milligram of OH minus ion, then 10 ml will neutralize the remaining CO3 2 minus ion, but that is only half of the total CO3 2 minus ion. So since it is only half of the total CS, so the total CS would be, total CO3 2 minus would be equal to 2 into 10 ml, that would be 20 ml. So 20 ml for CO3 2 minus ion, and then 1 ml for OH minus ion. We know the total is 30 ml, out of which 10 ml for CO3 2 minus, 30 ml is total, and then 1 ml for OH minus, and the remaining one, the 30 minus 10, so 20 ml for CO3, 30 minus 21 would be 9 ml for the remaining, that is HCO3 minus. So 9 ml of HCO3 minus consumes as CaCO3 consumes how much of if 9 ml of HCO3 is there, then acid is consumed, 9 ml of acid is consumed, how much HCO3 minus ion is there, right? So if there is 9 ml of acid is consumed, implies 9 ml of 9 milligram of alkalinity is there, but this 9 milligram of alkalinity is there in 200 ml sample. So then concentration is there in 200 ml sample, so concentration of HCO3 minus is 9 milligram by 200, 0.2 liters. So you can say this as 45 milligram per liter as CaCO3. So we have calculated concentration of HCO3 as CaCO3 equivalent, that is 45 milligram per liter, and what other one is asked, 5 concentration of OH minus ion, that is 5 milligram per liter. We also need to calculate for CO3 2 minus ion concentration. So concentration of CO3 2 minus ion would be, so this is 200 ml. 200 ml is there, which means 20 milligrams of CO3 2 minus is there, by it is present in 0.2 liter sample, so which would be 100 milligram per liter CaCO3. So we have calculated concentration of all the three quantities. And the next problem, the third question, a sample of water having pH of 7.2 has following concentration of ions. Calculate total hardness, non-carbonate hardness, alkalinity, and total dissolved salts. Also construct bar chart of ions. Okay, right. So sample of water having pH 7.2 has the following concentration of ions. Okay, so given the concentrations as ions, we have to express them in equivalent concentration as CaCO3. So for Ca2 plus, the concentration given is 40 milligram per liter. So if you express it as equivalent concentration, then 40 milligram per liter divided by its equivalent weight 40, then valency 2, so you get, then again with 50 gram per equivalent as CaCO3, get 100 milligram per liter. For Mg2 plus ion, concentration is 10 milligram per liter given. For Na plus, concentration given is 11.8 milligram per liter. K plus 7 milligram per liter. HCO3 minus 110 milligram per liter. SO42 minus 67.2 milligram per liter. Chlorine 11 milligram per liter. Right. So for magnesium, 10 is given, divided by its equivalent weight. Mg is 24.3 divided by valency 2 into 50 gram per equivalent of CaCO3. So this would be around 41.2 milligram per liter. Then we have 11.8 milligram per liter as Na plus divided by sodium weight is 23 and its valence is 1 into 50, so you get 25.7 milligram per liter. K plus, it is 7 divided by its equivalent weight is 39.1 divided by valency 1 into 50, so you get around roughly 9 milligram per liter. For HCO3 minus ion, given 110 divided by its equivalent weight 61 by 1 into 50, so this would be get around 90.2 milligram per liter. For SO4, it's given 67.2 the mass equivalent weight is 96 by valency 2 to 50, so this you get around 70 milligram per liter. For chlorine it's 11 milligram per liter divided by its equivalent weight 35.5 divided by 1 into 50 as CaCO3, so you get this all concentrations as CaCO3. This you get around 15 milligram per liter. All given the concentration, you divide it with equivalent weight, which is molecular weight divided by valency, you get the concentrations as CaCO3. Now we have to identify which of them contribute to total hardness, which of them contribute to alkalinity. We have to divide. So the first one is total hardness. So total hardness is basically contributed by the polyvalent or multivalent metal ions, which is concentration of calcium ions and concentration of magnesium ions. What are the concentration of calcium and magnesium ions? So which is 100 and 41.2. So which is 100 plus 41.2, which is 141.2 milligram per liter is the total hardness. The next one is non-carbonate hardness. So for calculating non-carbonate hardness, we need to calculate carbonate hardness first. So carbonate hardness is basically concentration of HCO3 minus ion plus concentration of CO3 minus ion. But since the pH is given, pH around 7.2, at this concentration, at this pH, the concentration of CO3 minus ion is negligible. So which means you can say carbonate hardness simply concentration of HCO3 minus ion, which is 90.2 milligram per liter. So now we got carbonate hardness. To calculate alkalinity, okay, before calculating alkalinity, we need to calculate non-carbonate. Non-carbonate is simply total minus carbonate, that is 141.2 minus 90.2, which you get around 51 milligram per liter. Next, alkalinity. Alkalinity is concentration of HCO3 minus ion plus concentration of CO3 minus ion plus concentration of OH minus concentration of H plus. But at neutral pH, these two are equal, so their difference can be negligible. Then again, the concentration of CO3 minus ion would be negligible at the pH 7.2. So alkalinity can be treated as concentration of HCO3 minus ion. So this is 90.2 gram per liter. Next, we need to calculate total dissolved solids. That is total concentration of ions, concentration of all ions. So just need to take sum as CaCO3, that is 100 plus 41.2, 100 plus 41.2 plus 25.7, 9 plus 90.2 plus 70 plus 15. So this comes around 257 milligram per liter. So this is the numerical problem set 2. In next video we will discuss numerical problems 3.